address codes are nothing but the codes that are going to contain 3 addresses for evaluations, right? So there are different kinds of code expressions, like I can compute x equals to y operator z, right? So what are three addresses here? X, y and z, right? Similarly, x equals to y, right? Third is equals to x operator z, right? Here how many? 2 only. Here how many? 2 only. So 3 address code says at most 3 addresses are required for writing an expression or for writing a code, right? So these type of statements are nothing but your expression statements. So let's move on how we are going to write expression statements. So let's take an example. X equals to a plus b, say, into e minus c into b. So this is my expression, right? I want to write 3 address code for this. So what I'm going to do is simply I'm going to use a temporary variable t1, which is going to be assigned as a plus b, right? Now I'm going to use a temporary variable t2, which is going to be multiplied with e, t1 into e. Now I have this expression. I have this expression as t1. I have this expression as t2. Right? Now I can use a third temporary variable, which is c into d. This is going to be assigned as t3. Now what I need to do is t4, which is going to be t3 minus t2 minus t3. So this whole expression is being related to temporary variable t4. Now what I need to do is assign this t4 to x. So x is equals to t4. So this is my basically 3 address intermediate code, right? So it's a very simple code generation, right? It's not a big thing to do. So there are many other expressions in the handouts, you can try them out, right? Now we will move to other part of statements, right? So expression statement that you have seen already how to write those, right? Few expression statements are there. Like suppose if I want to write three address code for x equals to a ka I. Now this is an array, right? How you are going to write a 3 address code for this? Okay? So for understanding this, we need to understand how this is being stored in the memory, right? So 3 address code is nothing but addressing the space in the memory where this addresses are being stored, right? So if I want to know the locations of specific elements in this array, I simply can write a formula as a ka I equals to base is what? Base address plus what? I minus low. What is this low here? I is the ith element, low is from where the index of this array is starting, right? Into world size, right? So let's consider this, like this is your array A, this is your 0th position, 1, 2, 3, 4, 5, right? And suppose this base address of this is 200, and as suppose this I am declaring this array as an integer array, right? So the size of one cell is going to be 4 bytes, right? The world size is 4 bytes. So this is going to be 204, 208, 2012, 216, 220 and 224. So in here, as I see, this base, the starting of this array is coming from 0, right? So the low value here is 0, right? So it simply is nothing but the base address plus I minus W, right? And in here W is what? Base address is what? Your 200 I is some ith position, right? W is what, your 4, right? So this is going to be 200 plus 4i ai. Now this has become a simple expression, right? Basically it's just a simple expression that can, now you already know how to represent as expression into a 3 address code, right? So in here you can replace this, right? And you can evaluate that value and transfer that to the X value. Now let's try a better example, right? This is just a single 1D array. So let's have a 2D array example and we'll see how the 3 address code has been written for that. Wait a second. So what we are going to have is 2D array, right? So for 2D array has a representation of a, I, comma j. What we can write here is base address plus, here it is, what I am going to write is I minus low into n2, or say the number of columns into n2. n2 is nothing but the number of columns, right? Plus j minus, and this is going to be a low one, right? J minus low 2, right? The whole into world size. Simply I am writing this, right? This low one is the starting position of the number of rows. This low 2 is the starting position of zeros. So you can clearly understand, if I want to know the position of A1, 2, I can know by, if 1 is there, then I have to pass the first row, right? The 0th row, that is, right? Then I have to come to the second row, and in the second row I had to move to second element, right? So this is for that, and this W is for the word size, right? So it is not a big deal to understand this, right? Now I have an let's try a question, right? So let's try a question. Write 3 address code for the following statement: x equals to a ka I comma j, right? Where the size of array is, say, 10 into 20, word size is 4 bytes, and low 1 is equals to, suppose 1, and low 2 is also supposed to be 1, right? So what we are going to have is, say, a ka I comma j is going to simply understand the base address. One information is missing here, which is the base address, and base address is equals to, suppose, 200. So a ka I is equals to base address plus I minus low 1 into n2 plus j minus low 2 into w. So now I can put the values in here. 200 plus, what is I minus low 1 is 1, n2 is 20, plus j low 1 is also this, into 4, right? So I am rubbing the question part. Right, so this is going to be 200 plus 20i minus 20 plus j minus I into 4, that is going to be 200 plus This is going to be 20I plus j minus 21 into 4. That is going to be converted to 200 plus 80I plus 40j 4j minus 84. Right? Now this has been subtracted from here. Now this is going to be converted to 116 plus 80I plus 4j. Right? So this is what your ai comma j. Right? So if this, I want to write this expression, or actually the expression was x equals to a ka I comma j, right? So now I can replace this I comma j with this x equals to 116 plus 80I plus 4j. Right? So if I want to write a 3-address code for this, what I'm going to write is T1 equals to 80 into I, T2 is equals to 4 into j, T3 is equals to T1 plus T2, T4 is equals to 116 plus T4, sorry T3, and lastly I am going to assign this T4 to x. Right? So this is basically how a 3-address code is being generated for expressions which contains your arrays or other variables kind of things, right? Like maybe a pointer or pointer array or those kind of things, right? Based on a particular formulation, those can be converted to a simple expression and then can create into 3-address code. Right? Now let's move on from expression to our flow control. Right? Flow control statements. So what are flow control statements? Simply if statement or statement. So if I want to write, say, if A greater than B, perform A equals to A plus B, else A equals to A minus B. Right? So suppose this is your expression. So let's write it in this way so that I can continuously write in here. If A is greater than B, A equals to A plus B, else A equals to A minus B. Now if I want to write this, right, so you can clearly see this is what if statement is what? A conditional jump. Right? If it is going to be true, I am going to come here. If it is going to be false, a jump is going to be performed from directly from this statement to this statement. Right? So what I am going to write in here, if A is greater than B, go to L1, else go to L2. So L1 is what? A label which is going to be T1 A plus B A equals to T. And after executing this, I want to come here, right? I don't want to execute this, so I am going to write here one go to statement. I will write one tag in here afterwards, right? So if this is not going to be true, if this is going to be true, this is directly going to jump in here, right? Then this statement is going to be skipped, right? If this is going to be false, this is going to come in here, and this is go to L2, right? This is just an else kind of a jump, right? So L2 is going to be here, and L2 is going to contain what? The part of else, A minus B, and then A equals to T1, and again a go to, right? So go to, say suppose this part contains some other kind of a code. So just I am writing go to last. which is somewhere last in here, right? To keep continuing the part of the expression. This is just a single part of our language, right? This is a single portion of the code, right? So this is going to be other code also. So I'm just trying to write the part of this statement. Okay? So this is how we write 3 address code for a control flow statement. Now this is for if statement. Let's try to understand for a switch statement. The others like while and for loop, you can try it by yourself, right? So switch statement, right? Switch A plus B, or simply write switch A. Now case 1, which says suppose printf, not printf, I will explain you printf afterwards, how to write this printf. Let's write an expression in here first. Let's say c equals to d plus e. Case 2, let's write, I'm writing in here the break. C equals to d minus e, break. And I'm writing a default case, right? Default case is C equals to D into E. So this is my switch statement. Now I will see how I'm going to write this switch statement into a 3 address code, right? So we're writing a switch statement. First, this is being compared, right? This is being compared with the cases. How many cases are there? 1, 2, and 3 cases are there. So what I'm going to write, if this simply a statement, if A is just also a control jump, if A is equals to 1, go to, say, I'm writing a level L1, right? If this is not going to be true, right, what I need to go is check for other, which is if A is equals to 2, go to L2, right? So I'm writing, and if this is also not going to be true, where I need to go is on the default case. So I'm writing go to L3. So your L1 is going to contain T1, D plus E, and C equals to T1. And as again, and what I'm going to write in here is go to last. So this coming here, right? So L2 is going to be your T2, C D minus E, C equals to T2, and again go to last. Now your T3 is going to be here, which says T3 is going to be D into E, and this C is going to contain T3, and here is, say, suppose your last begins, whatever expression you give. So now you understand how we are going to write a switch statements into a 3 address code, right? So now you can also write for while statements, also for loops, right? So while writing for loops, what you are going to apply technique is a loop, right? So once you know how to use these, right, labeling, you can understand how the looping can be done also, right? So let's try. Now let's first look for functions or function statements or procedure statements, how we write those procedure statements, right? And then we will see some example which will combine all those, right? So functions, procedures, right? So suppose there is one function which says sum and takes 3 variables, right? 3 parameters, a, comma b, comma c, right? So if this function is being called, what kind of a 3 address code I am going to write is, I am simply going to assign all these 3 values T1 equals to A, T2 equals to B, T3 equals to C. Right? Simply I'm going to assign all those three values to some temporary variables. Right? Now what I'm going to write is parameter. Simply we write param T1, or just for indicating that this T1 is a parameter, right? Param T2, parameter T3. Right? Now once these statements are written, after writing these statements, what I need to do is I need to invoke a function call. This is a system call, right? Call the name of the function. Name of the function is sum and the number of parameters. How many parameters are there? 3 parameters are there. So this is simply a way of writing 3 address code for a function call. Right? So let's try to understand this by an example. This is an example of a user-defined function. Let's try to understand this through a system-defined functions like printf. Right? So if I have given a code as printf hello world, right? So same again, similarly what I'm going to write is T1 is equals to hello world, parameter T1, and again what I'm going to call is call printf. How many parameters are there? There is only one parameter, right? Suppose in the case if I'm writing printf a comma b, right? So this is going to be T1, this is going to be T2, this is going to be T3, and here what I'm going to do is call printf. How many parameters are there? 1, 2, 3. So this is how your printf function actually works, right? Okay, so this is how we write 3 address codes for our parameters, right? Parameter functions. Now, actually, we will try to understand basic more of the flow control statement. Like we have seen if statement or switch statement. Those are mostly, we can say, controls this statement, right? Now, if your expression is like this: if A is greater than B, or C is greater than D, and F is equals to E, right? This closes here, this closes here, this closes here. So if this is going to be true, then I'm going to have some expression say y equals to x into z, right? Else what I'm going to have is say y equals to x minus z, right? So if I want to write a 3 address code for this, how are you going to write the 3 address code? Okay. Right? So first I'm going to write the if statement. If A is greater than equals to B, right? Go to some level. Now there are too many statements are here. So if I write level 1 L1 here, I don't know how many statements I need to write in here, right? So for writing 3 address code for these kind of expression, what the system does is it generates the normal code first without any label in here, right? Then after generating the code, it backtracks or backpatch kind of thing. So what it does, it comes again back wherever it sees a go-to statement again, and then it writes a label in here. So same thing I'm going to do. So if this is going to be true, then I don't need to check this, right? So if this is going to be true, I don't need to check the further statements, right? So I directly jump onto some level and I won't write in here, right? Now, if this is going to be false, then I need to check this. So if C is greater than D, then go to some level. Otherwise, if it is false, go to some other level, right? So again, I am writing the other statement. If f is going to be equals to e, go to some level, and if this is going to be false, go to some level, right? Now from here you understand, if c is greater than d, if c is greater than d, right, this is true, I need to check this also, that whether this is true or not. So I need to come in here, so I can mark this as some level. So I will see afterwards, right? So this is what it is going to have. So this is I have written, and now I am going to write for code for this expression also, which is going to be t1 equals to y into z, right? Y is equals to t1. Okay. In here also, after executing this, I need to go to some place, right? Like coming in here. I don't want to execute this, right? So again, the same thing here. T2 is equals to x minus z. Y is equals to T2. And again go to. And I know for sure that there is going to be level, which is going to be in here last, right? Which is going to indicate in this process. Now I can write levels in this, right? After coming in here, I've written all the text, right? So let's suppose this is your L1, right? So if this is true, if this is first I need to understand this. So if this is true, I am directly going to jump in here. So let's write this right in here as L1, right? And I'm going to write it here as L1, right? If this is going to be false, this is going to check this. It is by default thing. If this is going to be false, this is going to execute the next statement, right? While executing this statement, if this is going to be true, this go-to is going to check this statement, right? So I'm going to write L2 in here and L2 in here, right? If this is going to be false, right? So this is already false and this is false. So if this is false, no use of checking this, right? So I'm directly going to jump onto here. So let's say I'm writing this as a T3, L3, go to L3, right? So if this is true, this is going to come in here. If this is also true, again I'm going to come to L1. If this is not true, then again where I need to have, go to L3 here, right? So after executing this, what I'm going to write here is go to last, go to last. So this is how we write a 3 address code for expressions like this, and how the backpatching process is being applied, right? So one in the initial phase, what I do, I write the whole code, right? And then afterwards, because initially I don't know where these addresses, what are the addresses of these expressions are going to be in the memory, right? So what I do first, I write the whole code in the memory, and then I backpatch, and then I write the targets of the go-to statements, right? So this is how the 3 address code works, right? So for writing these 3 address code into the memory, we use different kind of techniques, 2 different kinds of techniques basically. The first one is your quadruples, and the other one is your triples, right? Quadruples. So quadruples are nothing but way of representing your 3 address code. So 3 address codes are what? You are going to have 3 different addresses, and one is going to be, one extra one is there, which is actually storing your result, right? So this is going to be your, say, expression 1, say operator 1, this is your operand 1, this is your operator, this is your operand 2, and this is your result, right? So let's say if I am having an expression says a equals to b plus c minus d. So it is nothing but the first thing what I am going to write is here is a b plus c, and I am going to store it in a t1, right? Then this t1 minus d, this is going to be stored in t2. Then the result t2, sorry, this result t2 is going to be stored in, there is going to be nothing, this is going to be stored in A. So in here, as you can clearly see, the table is being occupied with temporary variables also, right? So these temporary variables are nothing but just convenience for us to add things and store them for a temporary purpose. So if these are occupying most of the space in the memory, then it's an overhead for us, right? So for removing these kind of overheads, what we use is the triples, right? So in triples, there's only one thing is being removed in here, and that is the result part. And for including the result part, what we do, we use the addresses of the memory. So suppose this has been 100, this has been 102, this has been 104, and so on. We use listing of the addresses, right? So what I am going to here is A, the B plus C, right? This computation is being stored at the location 100. So if I want to use this, what I am going to use is 100 minus 100 as an intermediate address, right? So you have studied this in also in computer organization. So if I'm specifying this as an intermediate address, that means it contains some value that needs to be used here. 100 minus D. Again in here what I'm going to use is 102 minus 100 minus D is simply going to be the address value 102, and this operator 1 is what your A, and this is going to be equals to, and this is going to contain nothing, right? So these are what your triples. So simply write here as a NIL so that you won't confuse between a minus sign in the middle. Okay. So this concludes the end of how your intermediate codes are being generated, right? Now we will see afterwards the way of how optimization techniques can be applied to this. Thank you.